All right, chapter 8.3 is going to give us the skills necessary to graph what we call a reciprocal function. It is the function where you have a number on top and a function on the bottom. And this function right now is going to be basic, but some key ideas to note about it is that its name is called a hyperbola. Domain and range are non-zero numbers in the parent function at least, and the asymptotes, which would be vertical and horizontal, are x equals 0 and f of x equals 0, or as we will say, y equals 0. The graph shifts based on other values, as we'll see in our work, but pretty much the general idea before we get to it is to graph the function. Here's your steps. 1. Identify the horizontal and vertical asymptotes. 2. Choose an x value to the left and right of the vertical asymptote. 3. Plot the ordered pair based on those x values and sketch your hyperbola. So, I mean, there's really nothing to it. This is actually a decently quick video, which, you know, is different than what we did definitely last week, but just make sure you get the concept, because if you don't, it's going to be an issue there. So when we consider this graph, they want to know what the vertical asymptote is the one that goes this way, and that is the one based off of x equals. So your x equals asymptote is going to be whatever breaks the function. So what we're looking at here is 4x minus 1 equals 0, which from our work means we send the 1 over, making it positive, divide by 4. Again, you can do the algebra, but the asymptote is 1/4, which we're going to turn into a decimal, I believe, which is 0.25, so you would say 0.3. So our vertical asymptote would be x equals 0.3. Again, I believe it's going to have you round to the nearest tenth, and so 1/4 being 0.25 would be 0.3, but adjust accordingly. Horizontal asymptote is based off of this idea. It means what value is it going to approach as this number gets bigger. When you think about horizontal asymptotes, and this is a calculus / pre-calculus thing, but mostly calculus, you imagine x being very, 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 very big. Biggest number you can think of. And when you take that number and multiply it by 4, it's going to be 4 times as big as that. And you subtract 1, which just means it's a very big number minus 1. So if I were to take and do this pattern for you, 5 divided by 10 is 0.5. 5 divided by 100 is 0.05. 5 divided by 1,000. Just watch the pattern of the answers, and it'll tell you what the asymptote is, because your common sense can tell you the rest. Now, every 0 I add makes the number smaller by putting another number in front of the 5. So if I put 1 billion ones and 1 billion zeros after that 1, then more than likely there's going to be close to 1 billion zeros in a 5, and that number you're looking at is 0. Even if I do that with 5 divided by negative 1,000,000. I didn't mean to do that, but that negative 10 means there should be 10 zeros in front of it. It's a negative 0.5, but again, that's pretty much very small negative number, which is still 0. So the horizontal asymptote is y equals 0. And as I said in the part there, it's typically going to be y equals 0 for this, because that's just how it sets up. So when you're talking about the 2 points to use, it's going to be based off of your x. And so since x is at 0.3, just imagine that's 0, that's 1, 0.3 is here. What you want to do, if this is your asymptote, and again, that's not exactly where it's supposed to be, is pick the first whole numbers to the left and right of that asymptote. So the first one you would use is x equals 1. And so you take 1 and you plug it in. I hope you could see that 1. So again, 0.3 is about there. The first value to the right is going to be 1. So we take 1, that's 4 times 1, which is 4, minus 1, which is 3. So 5 divided by 3, which is going to be it. And again, if you're rounding to nearest tenth, it's going to be 1, 1.7. The number to the left is 0. So you take 0 and plug it in. So 4 times 0 is 0, minus 1 is negative 1. 5 divided by negative 1 is negative 5. And so those would be your 2 points. Again, if it turns out to be a decimal, round to the nearest tenth. But here's how you graph it. 0.3, again, if that's 1, is about, I don't know, it's not going to be perfect, but we don't need it to be perfect. So somewhere around there. That is our vertical asymptote. 1 goes over to 1.7. So 1 and then up 1.7, so pretty close to 2. Again, doesn't need to be exact. 0, negative 5, so 0 here is negative 5. 1, 2, 3, 4, 5, which is here. And keeping in mind, this is your vertical asymptote, that's your horizontal asymptote. So what we're looking at is it's got to be within this range. It'll never touch this line, and it will never touch that line. So all you have to do to draw your hyperbola is pretty much sketch a line that has 2 asymptotes on it. So this is your point, which means it's going to approach here. It's going to approach the x-axis and turn and go that way. So that's your graph. You won't have to graph these, of course, because there really is no way to graph these things on MathXL. I think on your quiz you'll have to, so make sure you know what you're doing, because I'll probably give you a picture and say which one of these graphs makes the most sense, something like that. I'm trying to work on that now. But that's pretty much the idea that we're looking at. So the reason why all you need to do is find this, this, and these 2 points is because if you know what the asymptote is, and you can find a point on both sides of the vertical asymptote, then you pretty much know how to graph it. All right. Same thing, what's the vertical asymptote? So this time we will do, remember your vertical asymptote is x equals, so you're going to base it off of x, so 9x plus 5 equals 0, so negative 5 over 9, which if I do a fraction is negative 0.6. And again, based off of a number line, 0, negative 1, negative 0.6 is somewhere around there. So the 2 numbers I'm going to be looking at are 0 and negative 1. Anyway, horizontal asymptote's the same. No matter how big this number is, I'm going to do 7 divided by billion, 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 billion numbers. That'll be y equals 0. That number is just going to get bigger. It's going to be 7 divided by a big number, which is 0. So the 2 points we are going to use based off of this are 0 comma something and negative 1 comma something. When I plug in 0, I get 9 times 0, which is 0 plus 5, so 7 divided by 5. Again, you can feel free to plug that in the real way in terms of your calculator, but I think you need to work on using your head a little bit. 1.4 is where I am there. And then negative 1 gives me negative 9. Negative 9 plus 5 is negative 4, so 7 divided by negative 4, which is going to be negative 1.8. Keep in mind we're going to the nearest tenth when you round on this. So that's your 4 answers you're going to have. X asymptote, Y asymptote, and then the 2 points. If you were asked to graph it, which again I'm just kind of go through this with you, negative 0.6 is going to be slightly past a half. Again, it's going to be somewhere around here. And y equals 0, of course, is the x-axis. 0, 1.4 means go up 1 and almost a half, so somewhere around there. Negative 1, negative 1.8 means it's close to 2, so about right there. And again, looking at this, you're going to go close to the line, through the point, and then turn and don't touch. Close to the line, through the point, curve, and don't touch. That's it. That's your graph. So again, the graph itself is not hard once you understand how everything works. The key thing is when you get a decimal as your x-asymptote or as your vertical asymptote, you got to make sure you use the 2 numbers that are direct, the 2 whole numbers that are directly to the left and right of that decimal. That is how your computer is set up. If you choose anything else, it's going to mark you wrong. Although legally you could pick any 2 you want, you have to pick those 2 for the sake of your MathXL. On this one, vertical asymptote, 2x minus 4. Let's see, 2x minus 4 equals 0. That's going to be 4 divided by 2, which is 2. So that is my vertical asymptote. Horizontal asymptote, same thing. 3 divided by 1 billion is 0. 3 divided by negative 1 billion, still 0. So it's y equals 0. Which means that the 2 points I'm going to use, if you're looking at a number line, if 2 is here, the first number to the right of 2 is 3. The first number to the left of 2 is 1. So you're going to use a 1 and you're going to use a 3. Doesn't matter what order. If it does flip them around, just let me know and I'll fix it in the MathXL, but I think I set it up to take either order. Just make sure you put both of them in. But outside of that, yeah, plugging in 1 gives us 2 times 1, which is 2. 2 minus 4, which is negative 2. And 3 divided by negative 2, I believe, is negative 1.5, which it is. 2 times 3 is 6. 6 minus 4 is 2. 3 divided by 2 should be positive 1.5. And so again, when I go to do this, I'll go to 2, which is actually a number this time. Draw my asymptote through 2. Vertical asymptote's there. 1, 1.5. I'm sorry, 3, 1.5 is about here. Again, it doesn't need to be perfect. 1, negative 1.5 is going to be about here. And again, all you have to do is draw your line through it and just make sure it does not touch either one of those two asymptote lines. And that's all. So far we've seen the vertical asymptote change. We have not seen the horizontal asymptote change. Well, that does change, but it changes in a way that, again, for those of you who've been keeping up, you should understand. This is what changes the vertical asymptote, but if you think about it, it changed our parabola. It changed everything we've done. It's our exponential functions. That number out here means go up 4. So pretty much it does the same thing. So when it says what's the vertical asymptote, the value that makes this 0 is 1, obviously, 1 minus 1. So your vertical asymptote is x equals 1. Your horizontal asymptote is y equals 4. Remember, this one is the one you flip, which we did. This is the one you keep, which we did. So there you go. So the two numbers we're going to choose are the numbers to the right of 1, which is 2, and the number to the left of 1, which is 0. Then you're going to take your 2 and plug it in. 2 minus 1 is 1. 6 divided by 1 is 6. 6 plus 4 is 10. 0 minus 1 is negative 1. 6 divided by negative 1 is negative 6. Negative 6 plus 4 is negative 2. So draw your two asymptotes. The first one's at x equals 1. The second one's at y equals 4. We then go to 2 tens, so 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is about here. And then we go to 0, negative 2, which is about here. Something like that. But either way, there's your line. It's going to look something like this in general. Typically, whenever you do this stuff, it's going to be set up to where it's going to be multiple choice if you're really going to use it, or your teacher's going to show you how much precision you actually need in terms of what's going on. The reason my graph looks so messed up is because it's not put on a grid, and of course it's not going to be accurate anyway because each of these lines is different, each of those lines is different. But again, as long as you understand the general shape, that's really all I care about, so that you can do it later on. And then the last one, same thing. What's your vertical asymptote? Well, that's what makes that 0. That'll be x equals negative 3. The reason we don't have to solve it is because it's not 2x plus 3. When it's just x plus 3, we put in negative 3. The horizontal asymptote, if you remember, is like your y-intercept, which is negative 7. So the 2 points we use to create the graph are to the left and right of negative 3, so it should be negative 2 and negative 4. When I put a negative 2 here, I get negative 2 plus 3, which is 1. 4 divided by 1 is 4. 4 minus 7 is negative 3. When I put a negative 4 in, I get negative 4 plus 3, which is messing up. Negative 1. 4 divided by negative 1 is negative 4. Negative 4 minus 7 is negative 11. And so again, if you were asked to graph it, which you won't be asked to graph it, but if you were, here's what you would do. Go to your asymptote for negative 3. Go to your asymptote for negative 7. 1, 2, 3, 4, 5, 6, 7. Plot the 2 points, negative 2, negative 3, which is 1, 2, 3 about here. Negative 4, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is about here. And again, just draw your line so it does not touch the asymptotes in the picture. And just for proof, I hope I get this right, in a graphing calculator, you would have to use parentheses here. So parentheses 4 divided by parentheses x plus 3, close, minus 7. Let's see if it's close to what we did. Yes, it is. There we go. Same picture. So again, key idea, make sure you understand how to do that stuff, because again, that's going to be crucial for tomorrow's work. But that's how hyperbolas work. Other than that, good luck. And like I said, email me whatever questions you have. Just make sure you can show me your notes in terms of the work you did. Talk to you later.